So probably these are the formulas here. In the ninth class, we're going to talk about cube. Okay, we'll talk about cuboid, we'll talk about cylinder, sphere, cone, hemisphere, fructum of a cone. So cone, you know what is fructum of a cone. So this was removed from syllabus probably last class because of shortage of the portion many time in ICC and other board. What is fructum? Basically, if you cut this cone, okay, so if you cut this cone, so automatically you left with some kind of his shape like this. This is small r, we represent a capital R. So, like if you talk about state board and all, Karnataka state board, so they simply ask the formula. What is the formula of volume of spectrum? What is the formula of surface area of spectrum for 2 marks? So altogether you can understand how you did that topic. So the shapes, cube, all these shapes I believe you already know. What is the shape of cube? What is the shape of cuboid? So cuboid is basically a three-dimensional rectangle. So if we talk about a three-dimensional rectangle, it is called as cuboid. So cuboid, when we talk about cuboid, so in cuboid, the values are different. You have length, you have breadth, you have height, you have length, breadth, and height. So if length, breadth, and height all become equal, it become a cube. Okay, cylinder, when we talk about a cylinder, so this we called as a cylinder. Okay, and then sphere, three-dimensional circle, we called a sphere. Cone, 1/3. So if imagine if you take a cylindrical beaker having a radius r and the height h, and the liquid, you fill this whole cylinder with some liquid and you pour this content in a cone having the same height, and the radius, then how much cone you require to pour the liquid from the cylinder over the same dimension of cone? You need 3 cone, because the volume of cone is pi r square h, and the volume cylinder is pi r square h, and the volume of cone is 1/3 pi r square h. So that way you can understand. So what is cone? What is cone? What is cylinder? This is called slant height. L we represent as a slant height. It follows the formula of Pythagoras theorem. You can get the value of L by using this formula, that L is equal to under root of h square plus r square. With that you can get the formula of L. Okay, so all these are solid figures about whom we are going to discuss now. Now, what is surface? Surface is a plane figure. Surface area, or the total surface area of a cube, when we say it is 6a square.
6a square.
How you derive this formula 6a square? So basically, when we say a rectangle, so when we say rectangle, rectangle area is length into breadth. You know the rectangle area. When you talk about a cuboid, cuboid is basically, it have 6 faces. When you say cuboid, it has 6 faces. If you count the number of rectangles, how many rectangles are there? So it have actually 6 rectangles. So you can see this is 1. Okay, this would be 2. Then this is 3. Then this is 4. Then this is 5. Then this is 6. So
yes, sir.
6 faces, and each face, if this is L and this is B. So if you count, like, so top and bottom we assuming. So it have, if
So TSA of cuboid is 2LB plus BH plus HL.
yeah, so this is 2LB. So 2LB for ceiling and floor, 2LB. So the LB plus LB, similarly breadth and height you can do 2BH plus 2LH. So that is the total surface area of a cuboid. When we talk about cone, in case of cone, length, breadth, and height all are equal. Cone I'm telling here again, cube. When I say cube, when I'm talking about cube,
So 6a square.
yeah. So when I'm talking about cube is basically, it's a 3-dimensional square. So here everything is same. So there they have every length, breadth, and height, everything is same in them. So you can say 6a square. Suppose a is the edge of the cube. So that way we can understand the formula. Lateral surface area of a cube, when we say
4a square.
4a square lateral surface area, basically means we are not including the area of ceiling and floor. So
Yes, sir.
then like imagine if you have cubicle room, and when you are doing painting of suppose, or you're putting some walls, you're putting some malwering, or you're doing floor malwering, anything, if you're doing maybe on walls you are doing something, so there you not include a ceiling and floor. So let that there we can use, like there's something called what you call area of four walls of the room. So there's a concept called area of four walls of room. So in case of cuboid, when so the same thing when you
Yes, sir. Lateral surface area of a room is equal to area of 4 walls.
so area of four walls of the room, when we say that is equal to the lateral surface area. So the formula, if you see in that,
4a square.
2HL plus B. That is the formula for that.
2HL plus B. Yes, sir.
So in that you don't include this. So you don't include the ceiling and floor in that. So that is what. So perimeter of a cube 12A, because you have all sides of equal sides. So that's why perimeter is the sum of all sides. Volume of cube is A cube. And the volume of cuboid is length into breadth into height.
Yes, sir.
So if they are equal, then it become L into L into L become L cube. Length of a diagonal of cube is root 3A. So three-dimensional geometry we require to understand, but basically we can understand probably by visualizing also the concept. So because whenever we talk about these topics like cube, cuboid, cylinder, square, cone, hemisphere, fructum, cone, everything is basically three-dimensional solid. So if you use the concept of Pythagoras theorem here, so ultimately you get the length of diagonal. Diagonal would be the longest length, or the maybe the longest rod what you can put in a room. So what should be the length of longest rod, that would be equal to the diagonal. In case of cuboid, the value of diagonal is under root of L square plus B square plus H square. In case of cone, in case of cube, the value of diagonal is equal to root 3A, because L, B, H all are equal. The total surface area of cuboid already we discussed. This is the formula. The lateral
Yes, sir.
cuboid already we discussed, which we called as the area of four walls of the room 2HL plus B. Volume cuboid is length into breadth into height. Already length of diagonal of the cuboid already we discussed. This is the formula. Area of whole wall of a room, that there you assume the room are of shape of cuboid only. The maximum length of rod that can put in a cube or cuboid is the length of its longest diagonal. Okay. So then talking about cylinder, the curved surface area of a cylinder is 2 pi RH. So when we say cylinder, its curved surface area. So you know this is 2 pi r. You know this value is 2 pi r. This is the circumference of a circle, and then you multiply with h. So with that you will get the lateral surface area. So the curved surface area of a cylinder is 2 pi RH. Okay, total surface area of cylinder. So when we say lateral surface area, so in that I'm not including the area.
Sir, 2 pi r, which is
So
lateral
in that,
surface area.
so in that I'm not including the area of base and the area of floor. So
Sir, TSA will be 2 pi r plus h.
yeah, so this is 2 pi RH plus, if this is area of circle, you know, pi r square. So pi r square for top, pi r square for bottom, this is 2 pi r square. Here if you take 2 pi r common, you will get r plus h as the formula. So this is what they have used. We need to clear with these things because it looks very simple. But imagine tomorrow you get some problem on mensuration where maybe some, you know, Rasgulla can and all. So maybe they put some questions based on that. So when you, if you will be talking about Rasgulla can or something, I remove the top part of that. I remove the top part of that. Okay, and then I put Rasgullas inside that, maybe something. And then I'm asking you, like, rasgullas are in the shape of spheres. So if I'm asking you some kind of question, that certain volumes will keep as a free volume, because anyway you can't use all the volume of the cylinder. So something based on area, if I ask you the question, there you need to understand that because already you removed the top part of that, so you cannot use 2 pi r square there. So there the total surface area available for you would be 2 pi RH plus pi r square. Plus pi r square will not be available because you remove the top part, because it is actually a cylinder having bottom part full, but the top part you have removed it. So you are getting that thing. So we need to, when we know the formula, so we need to also know where that formula came from. So the volume of cylinder, is pi r square h. Surface area of each base of cylinder is pi r square. Already we discussed that. There only we get this 2 pi r square formula. Then surface area of each base of hollow cylinder is pi r square, capital R minus small r square. So you understanding how that formula is coming. It is pi capital R square minus small r square. Suppose you have a hollow cylinder, something like a ring kind of question, something where you have something like this, So you have inner radius r and bigger radius called capital R. So if you want to find a volume, so this volume, this part you want to fill, to determine. So you can use this formula pi capital R square minus small r square under bracket. So going further, we can discuss external surface area, lateral surface area of hollow cylinder. You understand 2 pi capital RH, internal surface area, lateral surface area would be 2 pi small r is self-explanatory. Curved surface area of hollow cylinder 2 pi r 2 pi h r plus r. So you understanding this curved surface area when you talk about the curved surface area. So here you include the surface area of basically the external surface area plus internal surface area. So if when you include the internal surface area plus external surface area, only the difference parameter here is the value of r. So you include both of them here. So here you are taking the surface area of external part of the cylinder and the internal part of the hollow cylinder. Total surface area will be this. So you understanding total surface area, how you're getting total surface area. So how you are getting this is 2 pi r. This is capital R plus small r plus that is what is the total. So that it is total, that will be pi capital R square minus small r square. This is the surface area of top and bottom of the cylinder. So in that, if you see in that, here h is also there. So this is 2 pi h. So in this, what you take common. So now this r square minus capital R square plus small square is nothing but that is r capital R plus small r into capital R minus small r. A square minus b square is a plus b into.
Yes, sir.
You can simply take 2 pi, you get capital R plus small r common. So you left with r plus capital R h plus capital R minus small r common. So similarly, the volume of hollow center pi h capital R square minus small r square. This you can also write pi h r capital R plus small r capital R minus small r. Lateral surface area of a cone is pi RL, where how will you find the value of L? L is equal to root of h square plus r square. Total surface area of the cone. So when we say cone, the lateral surface area of cone you'll get as pi RL. Okay, and then this is the area of base also. If you include the area of base, it becomes pi r square. There you can take pi r common. So you will left with under bracket small r plus L. Volume of cone is 1/3 of the volume of cylinder. So that is 1/3 of pi r square h. We know the formula. Area of base of cone is pi r square. So base of cone already I discussed that pi r square. Volume of cone you can write this is 1/3 of base area into height. Somewhere that will also come into picture. 1/3 pi r square. So this is the area of base into height. So curved surface area of a sphere is 4 pi r square. A sphere is a three-dimensional circle. So like when you talk about Earth, so when you do any calculation on astrophysics on Earth, so there we'll consider Earth as a sphere. So its volume would be 4 by 3 pi r cube. The total surface area would be 4 pi r square. There's nothing called lateral surface area in case of sphere. In case of hemisphere, we will have lateral surface area and total surface area. So lateral surface area of hemisphere would be 2 pi r square, where the total surface area of hemisphere would be 3 pi r square. Okay, so just already I discussed that part. So 2 pi r square is the curved surface area or lateral surface area of hemisphere, and total surface area of hemisphere is 3 pi r square. Then volume of hemisphere is 2 by 3 pi r cube. That is the volume of hemisphere. Then volume of spherical ball. So volume of spherical ball is 4 by 3 pi capital R cube minus small r cube.
Sir, after class, can you send me this one?
Yeah, yeah. All these formulas, this chapter, nothing is there, only formula is there. What do you discuss? Then this square and all, when we talk about area, we square. So square, all sides are equal. All
Yes, sir. Perimeter is
particular
4 into
4a, and square diagonal is root 2a. You know that diagonals are equal. So all that is given. Area of square. Two formulas are there of area of square. Remember both the formula.
Sir, A square.
Or half d square. This half into d square. Actually, there's a half into d1 into d2. This is a formula of area of rhombus.
Yes, sir. Area of
So
rhombus
rhombus
is half into
half
D1
into
into
d1
D2.
into d2. But in case of rhombus, diagonals are different. Okay, so
Yeah, but, sir, this is the formula when the diagonals are given in the rhombus, right?
yeah. So rhombus, no, just d1, d2. Normally, no, in anywhere in exam, you will get very rare question where they expect you to work on the area of rhombus. You in rhombus, no, you should always remember the concept of Pythagoras theorem. So in rhombus, you should always remember the concept of Pythagoras theorem, that a square is equal to d1 square by 4 plus d2 square by 4. This formula, more than area formula in case of rhombus, you should remember more than that this formula. So 4a square is equal to d1 square plus d2 square. Because in rhombus, the diagonals are perpendicular to each other and diagonals are not equal. So this formula is more important in case of rhombus than the formula, area formula, which is d1 d2 half into d1 d2. In rhombus, all sides are equal, diagonals are not equal. Diagonals bisect each other and they bisect each other at right angle. In case of rectangle, the diagonals are not bisecting at right angle. In case of rhombus, the diagonals are bisecting at the right angle. Okay, so
Yes, sir.
remember, and very important thing, one more thing you can remember. So if I join the midpoints, if I join the midpoint of the rectangle, if I join the midpoint of the rectangle, if I join the midpoints of the rectangle, so the parallelogram जो मुझे मिलेगा, the parallelogram what I will get, the parallelogram obtained if I join the midpoint of a rectangle, the parallelogram obtained, this comes in theorem also, obtained is a rhombus, and vice versa. So if you join the midpoints of a rectangle, what you get is a rhombus. So this comes in many exams to prove it. So if you join the midpoint, if you take the midpoint of a rhombus and if you join them, you'll get. If you join them, then this is a rectangle. You'll get an exam to prove it. That's all together different thing we'll do in future. Similarly, if you take a rectangle and if you join the midpoints of the rectangle, you'll get a rhombus. So what is square? Square is a parallelogram which contains the property of rectangle and rhombus both. Rectangle.
Yes, sir.
So what is a rectangle? Rectangle, all sides are perpendicular to each other.
Yes, sir.
Sides are not equal. If they become equal, they become square. Okay. So in US and all, they they put square different, rectangle different. In India, we say square is after all a rectangle. So if you get some questions on data sufficiency in other exams, so when I'm saying square by default, that means it's a rectangle. When I'm saying rectangle by default, it means it's a parallelogram. When I'm saying parallelogram by default, it means a quadrilateral. So I heard that in US and all they put them little bit separately. They study them separately. I don't know exactly how they do, but that I just got to know from one of the seminar I attended where one speaker was telling like that. But even then, forget that. So rectangle, when we say rectangle, all sides are perpendicular to each other. The diagonal of a rectangle is equal to under root of L square plus B square. In case of rectangle, the diagonals are equal. If the diagonals are not equal, it becomes a rhombus. Okay, so the parallelogram are of two types. Parallelogram is either rectangle or rhombus. So in case of rectangle, the diagonals are equal. Diagonals bisect each other, but they are not bisect.
They are not. Yes, sir.
That part you can remember. Perimeter of rectangle is 2 into L plus B. Diagonal part already explained you. Triangle, we'll you study heroine formula. So that is there in our course. So where we'll study this formula. So area of a triangle. When you talk about a triangle, when you are talking about a triangle.
The area of a triangle is half into breadth into height.
That is one formula of area of triangle. A lot of formulas are there. A lot of formulas of area of triangle. When you actually study the properties of triangle, half into base into height is one of the formula. So area of a triangle formula when I talk about one of the formula is half into base into height. Another formula of area of triangle is under root of s into s minus a into s minus b into s minus c. Okay, where what is S? This is called Heron formula. S is equal to saving perimeter. You have altogether one chapter in your CBSE 9th curriculum where we'll focus on this only. We will study to understand the area concept of triangle. So this is this formula we generally use for scaling triangle. So we generally use this formula for scaling triangle. So what is basically a scaling triangle? So when you talk about a triangle, when we are talking about a triangle,
The scaling triangle is a triangle in which all sides are different.
Yeah. So very good. So you can talk about triangle on the basis of sides. You can discuss a triangle on the basis of the sides, or you can discuss a triangle on the basis of value of angle. So on the basis of sides, if I talk to equality of sides, a triangle can be scalene triangle, a triangle can be scalene triangle, it can be isosceles triangle, it can be either isosceles triangle or it can be either equilateral triangle. It is either equilateral triangle. So where all sides are equal, it is an equilateral triangle. Where the only two sides are equal, then it is called as isosceles triangle. Scalene triangle where none of the sides are equal. So generally we use this formula for scalene triangle. Like now just you understand this is isosceles triangle. Understand if this is an isosceles triangle. If you draw a perpendicular on an isosceles triangle, if you draw this is isosceles triangle, these two sides are equal. And now if these two sides are equal, this angle will be also equal. Okay, now if you draw a perpendicular on this isosceles triangle, it will always bisect the base. This is a theorem. You can prove it. So consider triangle, you can consider triangle ABD and ADC. You can consider triangle ADB and ADC. So in that triangle, AB is equal to AC. Okay, and then angle ABD is equal to angle ACD. BD is equal to DC. So by SAS congruency, you know congruency, right?
Yes, sir.
Congruency, similarity. We studied all this no, in 8th standard. If you don't know, I'll teach you. You don't need to worry. You studied no? Pakka. So congruency.
Yes, sir. Side angle side.
Yeah, of course.
Yes, sir.
Congruency, similarity. So by SCS congruency, you can prove that both triangles are congruent. So if triangle ABD is congruent to the triangle ADC, so then I can say that, so okay, I said BD equal to DC. Okay, that is theorem. Sorry. So that is theorem only BD. That I have to prove. I wanted to prove this, and that I took in theorem. So I wanted to prove BD is equal to DC. Okay, so to how to prove what is given? If this is a isosceles triangle, then what is given that AB is equal to AC, and then angle ABD equal to angle ACD. Okay, and then what else? The side AD, and the side AD is common side. AD is the common side. Okay, and I'm drawing a perpendicular. What is the construction I'm doing? Construction. What is the construction I'm doing? So I've drawn a perpendicular. So AD perpendicular on BC. This is the construction I'm doing. And what I'm trying to prove that this is a theorem, remember, in case of isosceles triangle, in case of isosceles triangle, in case of equilateral triangle, if you draw an altitude or height on the base, that will always bisect the base. That is what I'm trying to prove. So if you see this side is common, if you see this side is common, this is 90-degree and this side is equal. This is given. So what you can do now, if now you know that triangle, you know the triangle ABD, and you know the triangle ACD. They are right angle triangle. You know that, right? Because it's perpendicular.
Yes, sir. Yes, sir.
Triangle. So if because they are right angle triangle, so by RHS congruency, by RHS congruency. RHS congruency means right angle, 90-degree, hypotenuse. Hypotenuse, you know, this is hypotenuse.
Yes, sir.
This is a right angle and one side is common. So by RHS congruency, you can say that triangle ABD will be congruent to the triangle ACD. Okay, so then if they are congruent, so automatically BD will be equal to DC. This happens in the case of isosceles triangle. This happens in the case of equilateral triangle. You can remember. So you can remember that part. Now, just by using this concept, you can find the area of isosceles triangle. If I ask you what is the area of an isosceles triangle, so what is the area of isosceles triangle? You can use half into base into height. You can use that under root of s into s minus a into s minus b into s minus c, or you can use this also. This is height. This is height. Suppose this is base, so this would be b by 2. This would be b by 2. Okay, this is height, and suppose this is a. Okay, this is a. So you know the Pythagoras theorem, and you know that a square will be equal to under root of h square plus b square by 4. So you know that a square is equal to 4h square plus b square by 1 by 2 and 1 by 2. So you can say a 1 by 2. So a is equal to 1 by 2. So the value a was the what you call a is equal to under root of this. You can say this. Okay, the value of a, this is a. This is a. You know this is the value of a. Okay. Now, what is the area of a triangle? Isosceles triangle, if you want, this is half into base.
Base into height.
Okay, so now what you can do, you can write half into base is b, and in place of height, if you apply Pythagoras theorem, so you know a square is equal to h square plus b square.
Plus b square by 4, yes, sir.
So you can say h is equal to a square minus
B square by.
So you can write h is equal to 1 by 2 4a square minus b square. Correct?
Yes, sir.
So, this is under root. So this will come out. So this, then this you can write half into 1 by 2, 1 by 2. This is under root of 4a square minus b square. So the area of isosceles triangle, if you see in books, that would be like this: b by 4 under root of 4a square minus b square. you'll find this formula in many books. Okay, so remember this part. Similarly, in case of equilateral triangle, when we say area of a equilateral triangle, area of a equilateral triangle, area of a equilateral triangle, we use a formula root 3 by 4 a square. You know that formula. How that formula comes? How that formula comes? Area of equilateral triangle. In case of, you know this, so remember this. If this is angle theta, if this is angle theta, remember there is another formula of area of a triangle. So there is another formula of area of triangle, that is half into product of two sides, AB, product of two sides. This is AC into BC into sine theta. Product of two sides and the angle included in them. So that is another formula of area of a triangle. In case of equilateral triangle, this angle is 60 degrees. These sides are equal. So this is half into AC. AC is A and BC is A sine theta. So sine 60 degree. Okay, you are not showing trigonometry. So half into A square. Sine 60 degrees root 3 by 2. So this is root 3 by 4 A square. I'll teach you when we'll do trigonometry. We'll try to take some basic class on trigonometry where I'll tell you this formula sine 60, sine 30, sine 45 degree. That is important. In other ICSE and all, they have in 9th standard only. So we'll study a little bit of trigonometry to understand the sine theta. I told you, in the case of right angle triangle, sine theta is perpendicular by hypotenuse ratio. Sine theta, cos theta, tan theta, all these are ratios. We call them trigonometric ratios. They're ratios. So perpendicular by hypotenuse is sine theta. Base by hypotenuse is cos theta. Perpendicular by base is tan theta. Anyway, I'll not put you there. So this is another formula of a area of a triangle. Half into any two sides, half into product of any two sides into angle included in that. So that is another formula of area of a triangle. So you studied here this area formula. Then I told you the third formula, half into AB sine theta. This is again another formula of area of triangle. Then the third formula of area of triangle is R into S. R into S. Now the question, this happen in this. What is R here? You know S is semi-perimeter. What is R? Small r. If you draw in circle, like this, the radius of the in circle is small r. And imagine if you draw a circumcircle. Imagine if you draw a circumcircle and the radius of the circumcircle.
It's capital R, yes, sir.
So then the area of this triangle, imagine the area of this triangle would be ABC by 4R. So basically, you get the in radius where, how you get the in radius. So in radius is basically the point of intersection or trisection point, whatever the point of intersection in radius is basically it is a point of intersection of all angle bisectors. So if you take a triangle and draw all its angle bisectors, okay, so if you draw all its angle bisectors of the triangle, I hope you understand what do you mean by angle bisector.
Yes.
Bisector. Angle bisector means you know how to get you can get the angle of this side B. What is this angle B you can get, and then you can draw a line which bisect this angle. So for each side, if you draw the angle bisectors from each side, for each angle, angle A, angle B, angle C, if you draw the angle bisectors from each angle and the point where they meet, wherever the point, all the three lines will meet, if you put your rounder at that point and put the another end of pencil over the side of the triangle, where is the side of the triangle is there, and then if you draw a circle, so if you draw the circle, then you realize that these sides know what you're getting. If you draw a circle, you realize that these sides will become the tangent to this smaller circle. You know tangent, Dhwani?
Yes, sir.
Tangent, do you know tangent?
No, sir.
Tangent मतलब क्या sir? What do you know tangent? If this is a circle, we'll study the chapter tangent circle in this class, the 9th class. So this is a circle, and if you draw a line on the circle near to circle such that that line only touch the circle at one point. It cannot touch the circle at more than one point. If this line touch the circle at 2 points, then this line is called a secant. And if you draw a line on the circle near to circle such that that line just touch and go, this line is called as tangent.
Okay, sir.
This line is called as tangent. So we'll study in circle chapter these things. So if you draw a circle where all the three angle bisectors of the circle meet, and if you put a rounder there, and the other end of the rounder we put considering this side over this as a r, so that would be the total length from one point of the rounder to the another point. And then if you draw a circle, that circle will be drawn as if the sides of the triangle become the tangent to the circle. So this circle is called as an in circle, and the radius of the circle is called in radius. Similarly, if you draw, if we see the point of intersection, if you see the point of intersection, similarly, if you see the point of intersection of all perpendicular bisectors, if you see the points of intersection of all perpendicular bisectors of all angles of a triangle, all angles of a triangle, you see the point where all the angle perpendicular bisectors of all the angles of triangle meet. Okay. Wherever they meet, that is called a circumcenter. That is called a circumcenter. That point is called a circumcenter. And from that point, if you draw a circle, on that point, if you just suppose they meet, all of them meet at this. So if you draw a circle where you put your rounder here, another end of rounder here, on any of the vertices of the circle, okay, then the circle what you'll get, then the circle what you will get, that circle will be like this. Okay, and the distance between the center of that point to the vertices of the triangle will become the radius of the circle. This kind of circle is called circumcircle, and the radius of that is called a circumradius. So if you consider the sides and the circumradius, then the formula of the area of the triangle will become ABC by 4R, where capital R here is the circumradius, small r here is the in radius. So these all are the these values are basically these values you can use them for the area of a triangle. So this is the formula which I told you. This is the formula which I told you. So we can remember this formula. So these angles are now. So if this half AB sine C, you can see A B sine C. So and this angle. Then BC sine A. Then AC sine B. I hope you understood. This is again the area of the triangle. You understood, right?
Yes, sir.
Then equilateral triangle, you know the formula. Area of the equilateral triangle is root 3 by 4a square. You know this formula of area of equilateral triangle. Then this question comes in many exams. Altitude of equilateral triangle. What is the value of altitude of equilateral triangle? It is very easy. So this is BA. This is a by 2. Already I told you it will bisect the base. So what is the value of h? H value would be under root a square minus a square by 4. So the value of this h would be under root 3a square by 4. So the value of this h would be under root 3a by 2. So many exams and all, what they will do, they'll give you the side of the equilateral triangle. They'll ask you what is the value of its height. So either we can memorize it, or if we can remember the relation between the side of equilateral triangle and the altitude of the equilateral triangle, it will do well and good. Once you get this, if you want, you can use the same thing for the area, half into base into height. You can use this formula also. Base is A. What is height? Height is root 3a by 2. So you use that also you get the same.
Okay, sir.
Anyway, you can use, you can get the same. So isosceles triangle already I have explained you this formula, how you get this formula. So this is difficult to remember many times. So many, because this no, if you get some numerical on isosceles triangle and they expect you to find the area, then remembering this formula is difficult. But if you remember that if you draw an altitude that will bisect, and then you can apply Pythagoras theorem, so that way you can do it much more easily than to remember this formula. I've seen many of the students coming many times, and they're asking, sir, in that isosceles triangle formula, sir, what is A, what is B? They get confused that what is A. They many people remember the formula, but they'll confuse when the actual problem will come. They'll confuse that what is A, what is B. A is base or B is base, whatever. So best way is to you can use the concept of Pythagoras theorem. So and if you know the logic, then we never forget. So this formula also already I discussed. So this formula also already we discussed. ABC by 4R, where if the capital R is the circumradius and small r is the in radius. So this is how they, or the radius of a circumscribed circle is ABC divided by 4 into area of the triangle. So then this is given, this comes in area. In case of equilateral triangle, circumradius is equal to this. They have given this. I can ask you prove this. Prove this. Can you prove that in case of equilateral triangle, capital R is equal to A by root 3? If I ask you, in case of, if I ask you to prove this, maybe simply if I ask you to prove it. So in case of equilateral triangle, in case of equilateral triangle, in the case of equilateral triangle, okay, prove it. So what we do, capital R is equal to A by root 3. The small r will be equal to A by 2 root 3. Remember this. So many exams and all, they'll ask you that what is the ratio. They'll ask you that consider this is the equilateral triangle. Consider this is the equilateral triangle, and consider this is equilateral triangle. This, they'll ask you, tell me the ratio of area of circumcircle to the ratio of area of incircle. Or they'll ask you what is the ratio of capital R by small r. So one of the favorite concept which is very which comes in many exam and all, which you should always remember. So you know the formula, that area of triangle formula. You know the area of triangle, area of equilateral triangle, area of equilateral. So you know the area of triangle formula is ABC by 4R. You know area of triangle formula is R into A plus B plus C by 2 the semi perimeter. You know this formula. You know this formula. Already I discussed this formula to you. So what I can do in case of equilateral triangle, 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 what is the formula of area? That is root 3 by 4a square. So here a, b, c by 4r. You can equate this. Okay. Then you can write the same thing as root 3 by 4 a square is r into a plus b plus c by 2. Can you understand?
Yes. Yes, sir.
So now in case of equilateral triangle, A equal to B equal to C. Lateral triangles, you know that lateral triangle they are same only. So I can say root 3 by 4 A square is equal to A cubed by 4R. This is root 3 by 4 A square
A square is equal to, yes,
A
sir.
by 2.
Yes, sir.
So here I can cancel this. This becomes A. 4 and 4 I can cancel. So it means
Root 3 is equal to A
by
by R.
capital R. So I can say capital R is equal to A by root.
A by root 3.
Here I can, so this become root 3 because 3 is root 3 into root 3.
Yes, sir.
And this is A.
Yes, sir.
So this A by 2
A by 2 is equal to R
into
root 3.
So I can write R is equal to A by 2.
A by 2 root 3.
So remember this. So in case of very important theorem, or you can always remember. So in case of equilateral triangle, in case of equilateral triangle, in case of equilateral triangle, the ratio of circumradius by inradius is 2:1. Very important. Never forget this. Okay. So
Okay, sir.
generally, capital R by small r is greater than equal to R. This has been proved by other way. So, but you can, for equilateral triangle that become equal to R. And then if I talk in the term of ratio of area, so area, so pi capital R square by capital small r square, automatically that will be 4:1. So the area of circle by the area of in circle in case of equilateral triangle, the ratio of the area will be equal to 4:1. Understood?
Yeah, yes, sir.
So remember this. Then if I talk about so this is in radius, this is the formula which already I discussed. So you know S is equal to A plus B plus C by 2. So area formula very important even in CAT or IP MAT and all. So they ask questions based on this. One of the very important concept you can remember. Okay, so remember this. One more thing you can remember that in case of right angle triangle, no? In case of right angle triangle, the what you-
Hypotenuse.
the half of hypotenuse, the half of the hypotenuse is equal is actually the point where the center of the circumcircle will lie. So imagine if I draw, imagine if I draw a circumcircle. Imagine if I draw a circumcircle. Imagine if I draw a circumcircle on a right angle triangle. So the point where all the perpendicular bisectors of the triangle will meet is actually at the point which is half of hypotenuse. So you can prove it through construction or you can prove it mathematically. So this you can remember. In the case of equilateral triangle, you can remember this. This relationship, based on this numeric relationship, many times the question comes in the exam. And if you talk about or not getting one concept of the R is equal to A plus B minus C by in radius relation in case of right angle triangle. We'll do when we'll do triangle. So you know the formula, area of the triangle formula, that is R into S. So where you remember this. So R is equal to area divided by semi-perimeter. You know this formula, remember this formula. Area is equal to R into S. So for in case of equilateral triangle, already I proved this to you. In case of equilateral triangle, in radius value, R is equal to A by 2 root 3. You're getting this, right?
Yes, sir.
So this similarity concept is there. So when we talk about two similar triangles, you can remember the two triangles. Two triangles are similar. Suppose triangle ABC and triangle DEF. So the sides given. So the ratio of the area of the two triangle will be equal to the ratio of the square of the corresponding sides is equal to the ratio square of median of the corresponding side is equal to ratio square of altitudes of the corresponding side is equal to ratio square of perpendicular bisectors of the corresponding sides. So the in case of two similar triangles, their sides are proportional. So remember that if the two triangles are congruent, then their sides are equal. While if the two triangles are similar, then the sides are proportional. The sides are proportional. Then the sides and medians are proportional. Sides and perpendicular bisectors are proportional. The sides and angle bisectors are proportional. And so the ratio of the sides or median, altitude, perpendicular bisector, angle bisectors, all are equal. The ratio of the sides are proportional there. And if you talk about the same ratio in terms of the area, then the area is equal to square of the sides, area is equal to square of the medians, area is equal to square of perpendicular bisectors, all that you can remember. So the ratio of area will be equal to the ratio of area of the corresponding sides. Similarly, the ratio of perimeter is equal to ratio of corresponding sides. Perimeter is again the sum of all sides. So area is square of the ratio of area is equal to square of ratio of corresponding side, while the ratio of perimeter is equal to the ratio of the corresponding side. So this is given. Now this in the term of median they given you the formula. So where M1, M2, M3 are suppose the median of the suppose where M1, M2, M3 they are median of the triangle, and SM is what the semi perimeter of the median. You know what is median?
No, sir.
What is basically median? Median height, you know, height or altitude, you know, 90 degree.
Yes, sir.
Opposite vertex, if that is 90 degree. So, so opposite, this is ABC. So if you draw a 90 degree, this AD is called height. This is called height or altitude. This is called height or altitude. While if there's a triangle, if there's a triangle ABC, but if there's a triangle ABC, suppose if you draw a line AD, suppose if you draw a line AD such that if this line bisect the base, okay, so in triangle ABC, in the triangle ABC, if AD is bisecting, AD is bisecting the base, base means BD equal to CD. Okay, then AD is called as median. AD is called as the median. AD will call AD as the median. You understood this, right? So we'll call this AD as a median. Okay, so if AD is the median, if AD is the median, AD is the median of the triangle ABC, okay, then remember that the area of the triangle ABD, remember that the area of triangle ABD will be equal to the area of the triangle ABC.
Yes.
How you can prove this? How will you prove this? So very simple.
Sir,
Imagine if you draw an altitude. Draw the altitude. Suppose A. Suppose if you draw an altitude A. What
so will we use Pythagoras theorem?
No, very simple. You have to apply the area formula. You have to apply the area formula. So you know what is the area of triangle ABD? Area of triangle ABD will be half into
Half into
base
yes.
BD.
Yes,
Correct?
sir.
And
Yes,
what is
sir.
the height?
BD.
Into height is AE only.
Yes, sir.
Remember that in case of acute angle triangle, no, their orthocenter. Orthocenter means where all the altitudes meet. Okay.
Yes.
Or where altitude of acute angle triangle will lie outside only. Orthocenter will lie outside only. For this triangle, where the if this is a triangle and A, B, C, so where it altitude will lie? Altitude is always 90 degree. Altitude is always 90 degree. So where the altitude will lie? Definitely outside the circle. So this is equal to half into BD into AE, and here the area would be ADC would be half into here CD into AE. Now you know already BD is equal to CD because you know the reason. And because you know, right? You're getting it right? Because this and this are equal. Because it's
Yes, sir.
is immediate.
Yes, sir.
So and A is common in both. So the area is always equal. You can remember.
Okay, sir.
So then there's another theorem is there related to a median that is called Apollonius theorem. Apollonius theorem spelling is wrong. So we'll discuss that in future. Also, you can remember that whenever where whenever if this is a triangle ABC, if AD is the altitude of BC, and if BE B is the altitude, sorry, if AD is the median on BC, B is the median on AC, and if suppose CF is the median on BC, the point where all the medians of the triangle meet, that point we call a centroid. G is called centroid. The point where all the median of the triangle meet, we'll call this point as a centroid. And always remember the centroid is 2/3 of the side of the triangle. That thing we'll study in future. The concept of centroid and all. Coordinate geometry, what we studied. So we can study when we study in future, there we'll study the concept of coordinate geometry on centroid and all. So centroid is basically the point where all the medians of the triangle meet. The point where all the medians of the triangle meet, that is called as centroid. Okay, so you know the point where all the perpendicular bisectors of the triangle meet, that is called circumcenter. Correct? Remember, right? I told you the point. I told you the point where
Yes, sir. Yes, sir.
point where all perpendicular bisectors of a triangle meet. The point where all perpendicular bisector of a triangle meet, where a triangle meet, that point is called a circumcenter. So if you that point as a center and draw a circle, that circle will completely will be drawn as if the sides of the triangle are its vertices, will lie in the circumcircle. If you take the point where all the medians of the triangle meet, we'll call that point as a centroid. Where all the angle bisectors meet, we'll call that as the incenter. You're getting the
Yes, sir. I got it.
so quadrilaterals and all. So quadrilaterals, when we talk about quadrilateral, so okay, before quadrilateral, so this is the formula. So this is the formula of area of the triangle. Where suppose if I give you all the three median M1, M2, M3. Suppose the three medians of the triangle are M1, M2, M3. Okay, and if I'm asking you the area of the triangle on the relation between the area of triangle and the medians. So this is the formula what you need to use, where what is SM? SM is the semi-perimeter of the median of the triangle. You understood this, right?
Yes, sir.
Okay, so we'll continue this tomorrow.
Okay, sir.
Concept on triangles and all, and the concept of their application in the case of geometry, mensuration concept, the areas and volume, other concept. We'll continue this tomorrow, and now we'll meet 6:30 and we'll do another chapter. Okay, then.
Okay, sir.
Okay, then I'll see you at 6:30.
Yes, sir.
Bye.
Thank you, sir.
So guys, I hope you have understood what all I have done in this class. So we'll continue discussion on this probably in my next series of videos. So in the next session, I'll continue my discussion. So this was overview where I talked about the relation between the area and volumes of different geometrical figure with respect of its correlation with respect to the concept of geometry, which you already know, or if that is very great if you know already, or how we can include them by bringing both the concept of mensuration and the concept of geometry all together into one nutshell in series of video. That was I was planning. So I hope you understood this. So we'll continue a discussion on this in next class because we don't want to make the session too much lengthy. So that is our intention. So I hope you like this class. Thank you everyone. I'll see you all tomorrow.